We're going to take a look at Math Counts 2019 chapter competition, just the team round, and we're going to break this into 3 different videos. I'm going to do 1, 2, 3, and 4. Then I'm going to do 5, 6, 7, 8, then finally 8, 9, and then I may save 10 for a 4th video. Anyways, here we go. For number 1, Dara creates 3 congruent isosceles triangles, each one of which has 2 legs of 7 and a base of 5. She joins these triangles together, gluing an entire side of one triangle to the entire side of another. So we can't have a side of 5 going to a side of 7 until she's all 3 shapes formed a single polygon. So what is the greatest possible perimeter? So I kind of like to draw this one out. So we have 7, 7, and 5. Now, the best way to have the largest perimeter is we want as many 5-inch sides together as possible. So obviously I want to connect them here. But now I have one more triangle to go, and I can't connect it along this 5-inch segment. So that means on one of these 7-inch segments, I have to connect another triangle. So here's a 7 and here's a 5. So, and I can't do this any other way. It doesn't matter if I put this triangle here or here or here or here. I'll still end up with the same perimeter. So I have 4 groups of 7. 1, 2, 3, 4. So that's 28 plus a group of 5, and that gives me 33. Number 2. Now, number 2 is pretty inquisitive. As soon as I saw it, I'm like, it's 25. It has to be 25. But the question is, why is it 25? Well, we know we're starting with a base of 5, and we're going to an exponent of 50. And since we have a base of 5, we have to have a multiple of 5 for n. So if I do 25, that means that I am taking a group of 5 from here and multiplying it here. Now, the rules of exponents say that if I have a base to a power, and then I take that power to another power, then I will be multiplying the powers together, right? So for instance, if I have a to the 4th, and I take a to the 4th to the 2nd, I now have a to the 8th. A little background knowledge there. So looking at this, what I'm really trying to do to get my 25 is I have 5 squared, right? Well, what do I have to multiply 5 by, or sorry, what do I have to multiply 2 by to get 50?
25.
25. So this would equal 5 to the 50th, because I would have to multiply these 2 things together. Well, 5 to the 2nd is just 25. So that would give me 25 to the 25th, and that's the situation that I'm looking for. So the answer is clearly 25. Loire brought 2/3 of his candy bar home. He brought 2/3 of his candy bar to school to share with 2 friends. Celine took 1/4 of it. Elliot took half of what was left. The final portion of that piece was split equally among the 3 friends. What fraction of the original candy bar did Celine get? Express your answer as a common fraction. So what I did here is I created a little bar. So here's 1/3 of a bar, 2/3 of a bar, and then I have the bar that's been eaten. So here's the whole bar. And I'm just using a visual then to describe the math that I use later. So then I know that Celine took 2 friends. Celine took 1/4 of the shared piece. So 1/4, well, if this is my 1 whole now, break it apart, so there's 1/4, So this is eaten by Celine. And so really she's getting 1/4 of 2/3, which is going to be equal to 2/12, which is equal to 1/6. So Celine in this section is getting 1/6. Then Elliot took half of what was left. So we have what was left here, right? So this is 1/3 plus 1/6, right? So 1/3 plus 1/6 is half. So this right here is 1/2 the bar. So, what's his name took half of this. So
That's 1/4.
Elliot just took 1/4 of the bar, right?
Which equals another thing.
And then they split the rest among the 3 friends. So here's half. And so now that means that the remaining piece is 1/4. And the 1/4 is broken into thirds. So 1/4 of a third is equal to 1/12. So that means Celine got an additional 1/12.
Oh, and
So 1/6 is 2/12 plus the 1/12, that's 3/12, which is equal to 1/4. So in total, Celine got 1/4 of the bar. All right, question number 4.
did you say one? No, you didn't.
No, I've done first 3. So number 4 is the first one that goes beyond sort of the intuitive. Now, the first question is, what is an annulus? Well, an annulus kind of looks like a donut, a 2-dimensional donut, where you have an inner circle and an outer circle, and we want to know the area of the donut. We don't want to know the inside, just the area of the donut. So what I did, or what we can do is we can, I'm going to draw a little grid here. And since all of these are, well, that's negative. So I'm going to draw a 4-quadrant grid. And I'm just going to estimate here, because in math counts you don't get graph paper. So I'm going to make an estimate here. So 0, -3, let's say it's about here. And then I'm going to locate the approximate locations of these points. So I have 2, 0, 10, 2, and 6, 6. And so I have a shape like this. When I spin this shape around, what will happen is this is going to clearly, this point is clearly going to, is going to clearly make my inner circle. So the question is, which of the other 2 points is going to make the outer circle? Well, this point is the farthest away from my center of rotation. So this point is going to be my outer circle. It doesn't look so much like a circle, but you get the idea. And this point is just going to be inside my little donut. So what I need to do is I need to find the radius from the point of rotation to this point and the point of rotation to this point, and that will give me the radius of my 2 circles, and then I can find areas. Simple enough. So I'm going to erase my rings just to make life a little easier. All right. So I need to find this distance. Well, you're not allowed to have a ruler, but we know the coordinates here. We know that this is 2, 0. So from this point, that is going over 2 and up 3. And using the Pythagorean formula, now we know the Pythagorean formula says we can find a side length of a right triangle if I have 2 of the 3 side lengths. So I can find one missing side length. And the Pythagorean theorem says a squared plus b squared is equal to c squared, where a and b are the legs of the triangle, and c is the hypotenuse of the triangle, the longest side length. So clearly this is my c value. Here are my a and b values. So we have 2 squared, which is 4, plus 3 squared, which is 9, is equal to c squared. So then we have 13 is equal to c squared. Take the square root, take the square root, and so we get this side length is the square root of 13. Now, I don't need to know the square root of 13 right now, because the area of a circle is going to require me to square the radius. And the square root of 13 squared is simply 13, because square root of 13 times square root of 13 is 13. So I don't need to worry about this. This radius is the square root of 13. So now I need to find this distance here, and I'll do the same thing with the Pythagorean theorem. From 0 to 10 is 10. From -3 to 2 is 5. So a squared plus b squared equals c squared. So I have 10 squared, which is 100, plus 5 squared, which is 25, is equal to c squared. 125 is equal to c squared, square root, square root. So I get the square root of 125 is equal to this distance. Okay. So now I can find the areas of the small circle and the big circle. So the big circle, we're going to have the area is equal to pi r squared, and that's how you find the area of a circle, which should be common knowledge, yes? Area of a circle, pi r squared?
They've never taught us that.
That's unfortunate. The area of a circle is pi r squared, pi being 3.14. Okay, so the radius is the square root of 125. So the area is equal to pi times the square root of 125 squared. Well, 125 squared is the square root of 125 times the square root of 125, which is square root of 125 times the square root of 125 is,
125.
there you go. So the area of the big circle of my annulus is 125 pi. Now, I'm not going to multiply 125 times pi yet, because it says express your answer in terms of pi. So that means don't multiply your answer by pi. For my smaller circle in my annulus, I have area is equal to,
125? No, 13? No, wait, what?
what's the equation for a circle?
Pi something squared?
Times the radius squared. My radius now is 13 for my small circle, so what is the square root of 13 squared?
13?
13. So the area of my small circle is 13 pi. Well, what is the difference? So if in an annulus, what I'm essentially doing is I'm finding the area of the big circle, and then I'm going to subtract out the area of the small circle. So the area of my big circle is 125. The area of my small circle is 13. I will simply subtract them, and I will get 112 pi. And that is my answer.
I only understood like half of that.
Okay.